So in the last video we created this TreeView that basically acts as like a mini file browser and mimics the folder structure on your machine. So we're going to now use this as an example to convert to a basic view model. So we have all the logic right now in the actual UI. So this is the class for the actual WPF UI. And we got, when the window loads, we query some logical drives, and we specifically create this TreeView item, which is a UI element. Then we add it, and then we hook into UI events to then do things. So this is very hardwired into the actual WPF application. So that means if we want to move it to Windows Forms, or we wanted to make this an Android app, or an iOS app, or a Linux app, or anything other than a WPF app, all of this logic and all of this expansion and everything we do here, it'd have to be completely redone. It's as good as useless because it's hardwired to a UI. So the point of view models is to separate the logic, like actually getting the folders and figuring out what the data is and whether it's a folder or a file or a drive and all that type of information. That becomes your data, and then you want a view model that then links that data and converts it into something that can then work with UI without knowing about the specific UI as well. And then the final step is to bind the view to the view model. So it's much easier to show. So the first thing we need to do is strip all this out and get it into its own classes. So we'll just make a new folder in the project. We'll just call it a directory because that's where all the directory stuff's going to go. I'm going to create a new class, call it a directory structure. And this is just going to be like a static helper class that's going to contain all the information for querying the directory and just generally getting information. So a helper class to query information about directories. So this is where the real data logic is going to happen. And then we're going to create a folder called data for now. Again, this would usually be in separate solutions or separate projects where your concerns are in different locations. So this is the UI, then you'd have this in another project, and you'd separate things. But for this small one, it doesn't matter. We'll just dump it in here. And then we basically want to create a data model for a directory item, we'll call it. So basically like a file, a folder, a drive. Anything that can be contained in a directory or the folder itself, the drive itself. So information about a directory item such as a drive, a file, or a folder. And this class is pretty simple. There's just going to be a name. Let's do that in a second. We've got the full path. And that's really all there is to it for the most part. So that's the path to the item. The name, we can then use this helper function that we already made, but right now it's just in this UI. So let's move that out. So we've got this helper. Let's literally just cut the whole thing out of the UI and move it to the directory structure. Let's add a little helper here. That can all stay the same. Get file folder name. So we'll just want a getter here, and it's a directory structure. Correct the namespace. Get file folder name of the full path. So there's no need to specify the name because the name is always going to be effectively this. So that's the name. And then if you remember, we did some logic somewhere where doing this on a drive resulted in a blank string. I think it was in the header item. Yeah, so like here, we check if it's a blank string. So we know the name really of a drive wants to be the full path itself, wants to be the drive. So in order to obviously know about a directory item as well, we need to type. So let's just create another class, and it's going to be an enumerator this time. We'll call it directory item type, I think. and then this is going to be enumerator, and we've got a drive, a file, and a folder that we know of. A logical drive, physical file, a folder. So now we want a directory item type as well. Cool. And that's really it. So that's now a data object, if you will. That's pure data about a directory item. So when we query all of the information, this is what we want about each item. We want the full path, the name, and what type it is, and that's enough. So we've got a directory item, we've got a directory item type, and then the structure now, ignore that for now. We go back to this class and we start at the top. So when the window's loaded, we do this to get a logical drive, and then we do all this UI binding, which we won't need. So let's just cut this first, and we can even get rid of the window loaded because we won't do anything on loaded now. Let's delete the loaded from here. There. And then in directory structure, one of the first things we want to do is to be able to get the logical drives. So that'll just be public static list of the directory item we just created. Get logical drives, and that'll be like the starter point. Paste that code in. We now want to do, we can really shorten this because this is a UI item now. We don't want a TreeView item. So that can all go. So we don't need to add, we don't need to listen to the expand, we don't need the folder to be added there. We also don't need to do a for each now, so this becomes really simple. What we need to do is return a new list of the directory item. In fact, don't do it that way. So what we want to do is the logical drive, then we want to select to cast it to a directory item. So just do the drive. We want to convert that to a new, well, convert each one to a new directory item. And then we just need to specify the full path is the actual drive itself. Ooh, I've spelt it wrong there. And the type is a drive. And then we want to just convert that to a list. And that's that function done. So this will return then a list of directory items based on this information here. So that's now a much easier function. You'll end up with a directory item for each one, with the full path being the drive and the type being drive. Now that reminds me, let's correct this. So now we know the type. If it's a drive, we want the name to be the full path, not the folder name, otherwise it'll be blank. So let's just do that. So if this dot type is a drive, then you want it to be the full path, otherwise you want it to be the folder, so that'll do that. So gets all logical drives on the computer. So that's got that content. And then get rid of the unloaded now. Minimize that. The next thing is when folders expand, we basically then get the sub-contents of the folder. So these checks can go because the view model is going to handle all this type of thing. So all that can go. And then really you're getting the folders and the files. So let's cut all of this, which then becomes the rest of that function. Get rid of that function as well. So you can now see already the UI's got nothing in. And then we need a helper, not a helper, we need another function in this, which is going to do the same thing. It's going to be a directory item. And we'll call it get directory contents. And this will then return the files and the folders. And we want to pass in the full path of, the content to get. gets the directories top level content, the full path to the content, to the directory. Let's just paste that in for now. And then what we want to change, we know we want a list of directory items, so create the list. And then for the get folders, we don't need to create this list now because of strings, because we've got a directory item. Let's get rid of that. And then in the try, you still want to get the directories, but now instead of directories adding range, you want it to be the items. And then instead of adding just a string, we need to do the same as we did with the last one. We need to do cast the directories from what they are to a directory item. So for each item in there, we'll create a new directory item. And that would work there. And then you need to set the full path to the directory and the type to a folder. And that's it for that. This is then all UI stuff again. So this was creating a tree view, setting the data, adding a blank item. All that can go again because we're not interested in that now. We're just literally asking for, a set of directory information. And then we do the same for the files. So that goes. Then we've got the files as now the items. This UI stuff here goes. Then we will return the items. And then we also need to cast the files to the same thing. So a new directory item. Full path is the file, the type is a file. And that's really it. That's the whole thing. That'll now get the contents and return a list of directory items. So that's already simplified. And I think that really makes up the whole directory structure. That's all you need to do to get data. And then you're going to get a list of directory items based on, even your logical drives are going to be directory items. So you can get the logical drives as a list, you can get the directory contents as a list. So now these two things are ideal to start working with the tree view. So this would be like your first list, and then each one inside would call get directory contents. But obviously when you start doing that, that becomes the UI. You don't mix this with the UI. So this is where the view models come into play now. This is where you need the bridge gap, if you will, between the data and the view, and that's what the view model does. So we'll create a view model now. You're going to need one for this directory item. So let's create another folder in here called View Models. And then we'll create another class, and we'll call it Directory Item View Model. And some people get concerned with view models and they think they're complicated, and linking in a model with a view is really complicated. It's not. So the simplest thing for a view model, let's just see if I can compile first. Let's just change this to directory structure. Will this compile? Yes, we can compile. So we just go to this view. Let's quickly just chuck this in a stack panel. Cut that out. Move that into there. Let's just add a button and some content. So the default content is test. We need a name for that. In fact, we don't need a name. So the way view models work is you bind this object in UI to an object, a view model, so that then it gets the content for it. So instead of finding specific elements here like the actual UI and going to the tags and stuff, you literally just bind directly to your content. So all the view model is, we just create a new class. I just literally call it class 1. So this whole thing, to make a view model, you just have a class like any other class. You just implement the iNotify property changed interface, and that's it. So that now is a view model. So we have to create the actual the event itself, because this is what gets fired, and that's it. That's now a view model. That's all you have to do. And all the view does, say we now bind to this class, because this is our view model. So in the window, the window, and the constructor, the data context is the root of the UI in terms of data binding. So if I set this data context to a new class 1, now in the view, instead of being test, if I do content is the binding, that's going to bind the content to class 1. And by default, because content will try and display a string, it's going to do class 1.toString, which will just convert to, I'm guessing, WPF TreeView.class1 or something, which it does. So it's already bound to this object. So if we just override the toString, and we could just return hello world, we're proving that we're bound to this object, and that's what's happening. So you can see there we're data bound. Now you don't usually bind to the actual view model itself, you bind to properties on it. So we make a property called test, and if we just did get and set, and we set it to my property, and we actually change the binding to bind to the actual inner element called test, you can see we get my property. So it's already a view model. Now the thing with this property change is when you bind here and you do this test, this content is now not only binding at the time of it loading, the initial binding, but it's then hooking in to this interface and listening at this event, and it's waiting for you to say that this property, the name test, has changed, and then at that point it'll go and refresh this property on the control. So if we went to, say, the class, we'll just do it in the class itself, we'll make it sort of self-aware, we'll just run a new task. It's completely just for a demo, just to show you what's going on, but also to show you just how easy view models are. There's nothing complicated there. And then we're just going to do, again, don't do this in the real world, this is purely a demo. We're just going to loop forever. We're going to await for 1/5 of a second, and we're going to keep an integer, and we're just going to set the property test equals an incrementing integer. So basically every 5 times a second the test value is going to change, and you can breakpoint to see it's going to change to 0, 1, 2, 3. So it's 0, it's my property now, then it's 0, then it's 1. So if you run this, you'll see that nothing's changing here. So it's still my property. The point of view models is whenever you change your property, your view's meant to update. And the trick is, what you've got to do, you can't just do this. You can, and I'll show you how in, after this video. At the end of this video I'll show you how to do just this. But all it's looking out for is you to tell it the property's changed. So one way, you could say here, you could literally just call, okay, the property's changed. So I'm going to call myself, it's this element, and the property test has changed. So this is going to fire this event, and it's going to pass in test as the property that's changed. This is actually going to tell the UI that this has been changed. And if we run that, it should work. You can see now it's bound to the UI properly, and all we need to do then anywhere in code is to change the string, and the UI will reflect that information. Now you don't usually do this here, this property changed here. You want it to happen automatically when you're working with a view model. You just want to set test and it should work. So the trick is here, you move this into this property. So now you've got to change it to an actual getter setter because we're doing custom code. So now we need a private backing field. We'll just call mtest. So we just return mtest. This is just standard properties. This is just how they work. If the test hasn't changed, so the value hasn't changed, just return. So if you set test to the exact same value, there's no point in doing anything else. If we get here, then we've changed. So then we do mtest equals the new value, and then in here we tell it the property's changed. And then we can make this nice. You don't want to hand type test, because then if I rename this to test2, this is then wrong. So you can just do name of test2, and that'll then turn it to a string of test2. And then if we go and rename this in code, that's always going to be the same thing. So this sort of setup now is a self-aware property. So all we do is set the value here, and now the UI should update automatically. And that's it. That is effectively a view model. That is the whole point of a view model, that in your code all you have to do is bind to a value in the view, and then in some non-view stuff, so anywhere in code, you can then just get this, whatever property you set as the view model here, whatever this is, this can be anywhere in code, you can then just directly change the values on it, and it will automatically reflect in the UI. So it keeps the thing setting this value as completely unaware of the UI, yet it will work in the UI. So a view model is nothing more than an object that implements iProperty notify changed, and then it should fire this property changed whenever, you know, a property's value is changed, like in this instance. And this is the default way to do that, is for each property to write this out. Now I was going to do this at the end of the video, but I might as well do it now. So just so you're aware that this is what's happening, there's no magic going on. You set a property, and then inside the property we call this event and tell that, you know, this event to fire, saying that we've changed. That's how it works. Now instead of having to write this for every property, which gets really tedious and annoying, you can go back to this, and you'll see this won't work now because there's nothing firing that property changed. But there's a little helper. So if we right click on references and add NuGet packages and then browse, and if you type foddy property changed, I think it's called, and there, property change.foddy, click install, just accept the license. This is going to add this really useful add-in here called Foddy Weaver, and it adds this little XML to your project that basically just tells it to include it, this property changed. And that's now added this Foddy Weaver. So all you have to do on the actual view model is to say implement property changed, and this little attribute here, when we compile the code now, if we had .NET Reflector I could show you, but now if we compiled, well, when we do compile this code, this Foddy Weaver is going to pick up the actual compiled code, so this normal property, and then because it's tagged here, it's going to find all properties, all public properties on the class. It's going to smartly detect when they're being, like if this is related to something else, like when this changes it sets another value. It's really intelligent. It figures out, you know, if you change this, what other properties it changes in the class. It works out the whole thing, and then it goes and injects the call to property changed for you. So it figures out the default code that we had to do to fire. Every time we change this, we had to fire this and pass in the name. This Foddy Weaver, after the code's compiled, goes and then converts the pre-compiled, the IL code, and injects these calls to property changed. So it effectively does that for you. So long as you've got this implement property change on your class, and you've got public properties, it will fire this property changed for you. And you can see that by just going into this function and putting a breakpoint, say. And if we compile now, so the only difference is we've added this implement property changed. When we change the value, so we'll run, and we're about to change, we run, and you can see it's now fired this property changed for us. And the property that's changed, if I could get this to go over, is test. So that's Foddy Weaver, that's what it's done there. We've called set, but this set, if we went into the actual IL code, which I think we can step into some way. Go to disassembly maybe. No, not disassembly. Maybe go to source. No, okay, so it's easier with .NET Reflector. I'll show you in another video. But what's happened is this setter is now as we wrote it before. So if we undid the code and went back to how it was written before, you'd see that this Foddy Weaver's done that for us. So it just means now we can just write a public property as if it's a normal property, and because this is tagged, you know what's happening. It's just calling this property changed for us. So that's your view model, and as you can see, you don't need that now, and you don't even need this. This is just changing the code. So there is your full view model. It's a notify property changed that is just a bog standard blank function because we don't need to do anything specific with it. It's just an event, and then you put the properties on. So effectively it's a normal class just with this and this tagged on, and that's it. That's a view model. So we'll get more into that now as we make them, but hopefully that's made you realise there's no there's no magic going on with view models. There's nothing hard. They are what they are. They're pretty simple. You just got to bear in mind that the view basically hooks into that property, then the parent of that property, it hooks into the iNotifyChanged, listens for that event to fire, and if it matches the name of this path, it will then go and ask for the new data and then update the UI itself. That's what the binding is doing. So take this back to what we were at, and then we'll just carry on, and we'll now make a view model. So delete that class. So we've got the directory. We'd started this view model, directory item view model, and it'd be a good time to now make a base view model. And the base view model is just going to implement that Foddy Weaver attribute and do the property changed event for us. So it just saves us doing that for every view model. So it's a base view model, it's an iNotify changed notify property changed. Couldn't think of the name then. And we also want the class to implement property changed. This wants to be the sender and the event. So there's your blank one. This is now base view model that fires property changed events as needed. The event that is fired when any child property changes its value. So that's pretty simple, base view model. That's what we've just done in the last one. Now this is a view model for each directory item. And then we want, in this directory view model, we'll have the full path again. So we just want a public string full path. We need a name again, just the same. Oop, that wants to be directory structure dot no, then is that right actually? Yeah, I'll have to do that same logic that's in the data. Might as well just copy that because that's exactly the same. So you'll see you're repeating parts of the data in here, but that's fine because this is, you only include information here that you need inside your view. So the view needs to know about the view, the full path, and the name. And then we'll obviously need this type. So I think we've got that in here as well. And you'll see in a minute why. You know, we've got all the items repeating, but we've also got additional things coming. So we've got the type, and that's required for knowing what icon we show. And then you've got to also have now an option for if you can expand for one. So the items in the view, the little drop downs, you need to know whether they can expand or not. Which actually, I don't think we'll end up binding this because that's worked out based on if there's children in the list in this instance, but we'll add it anyway because again for other UIs it would be useful. So can expand, and before we can do the expand we need children as well. So this is a directory item, so it could be like a logical drive, and then it needs its own children in order to step down and drill down further. So you can use a normal list, but in view models you tend to use an observable collection, which again is just a list that has another iNotify collection changed event, so that any view models, any UI listening out on lists will listen out for this collection changed, and when this fires it then rebinds the list item. So it's again, it's like a view model thing, it's a collection. They're the only two, as the notify property changed and the notify, you know, a collection has changed. So this is just a list basically. It's just a list that fires a a collection changed whenever you add and remove items. So that's all that is. So we'll have observable collections are basically a list of directory item view model, and this is the children. So it's basically a you know, a self-recurring list. This is the item, and then it's got children of itself, you know, the same type. So that's the children. There's nothing, again, nothing special about that. Can expand. We want to expand if the basically this dot type isn't equal to a file. So a drive and a folder can expand and a file can't. So indicates if this item can be expanded. A list of all children in this item. That doesn't really sound right. List of all children contained inside this item, something like that. So that's the can expand, and you can see now we're adding UI specific things here to the directory. So a directory doesn't care about, you know, can expand. It's got nothing to do with a directory. This is purely a UI thing. So this is where the view model comes into its own, where you start adding UI specific things. We also want to know if it's already expanded, because the view, when you're clicking the little expanding icon, this thing here, when you're clicking this to expand, when you click that, the UI is saying, well, am I expanded? No. Okay, so I need to expand. So it then sets that is expanded. So you'll find out that when you click this arrow, the UI itself will then set, if we bind it to, it'll set this is expanded property. So we want this to be a get and a set. So the get is when the UI is going to ask it is it expanded or not, and we're going to say no, so it'll show this. When we click the UI is then going to call the set and say, right, then it now needs to be set to expanded because we've expanded. So we want to know if it's expanded. So we're going to add a dummy item still, so we're going to have like a null item so we can show this icon. So we need to find the children and make sure we've got some first with a question mark, and get the count. We should be able to, oh, we haven't got a link included. Oops. We want the count of the children, but we only want children that aren't equal to null, because obviously null is going to be the dummy item. So if we have any children that are null, so basically we have any children, then we're expanded, because we've got children in the list, and that's how it's going to work. Then if we're not expanded, and the UI tells us that we want to be expanded, we then need to actually expand. So first you do the normal check. If the value is true, so this is the UI saying, right, I've expanded, you need to now actually expand. So we'll create a function called expand that will fill out in a min down here. Expands this directory and finds all children. So if the UI tells us to expand, find all children, and then if it's not, so if the UI then tells us to close, that's really simple. We just want to remove the children. So we'll just make a function, this dot clear children. I'll make another little function here. And that will just set this dot children as a new list. Oops. This dot children as a new list. Removes all children from the list, adding a dummy item to show the expand icon if required. So we clear all the children, but we've also got to bear in mind for directories, like for folders and drives, we need to show the expandable icon, this arrow here, and to do that we need to have at least an item in the list. So we need a null item, but only if it's a directory or a drive. So show the expand arrow if we are not a file. So if this.type isn't equal to a file, then just do this.children.add null. So this will always have a null item for those. And then this is expanded will also be correct. So if it's got if it's got an item, if it's got a child, it won't show because it's going to check first that it's not null. So this is expanded will match as well and be correct. So let's see as expanded. We can now clear children. That's a helper function, or helper method to clear the children. These are public properties. And you can see how this is more work than the previous way of doing things. But what you've got to bear in mind once you've done this now is this directory item view model and the whole structure that we'll do in a minute. This is completely cross-platform. So you can then take this to Android, to iOS, to Linux, to even on Windows. You can just redo the UI. The whole logic about how your program works, the thing about finding files and creating the structure, is now done here completely, and it's even UI aware. It knows that you expect it to expand or not. So to then change your UI becomes really easy. To just reuse the logic becomes really easy. It's completely separated the concerns. So your data is just that. It just gets, get logical drives just gets that. There's no bloat. It just gets the information. The directories gets the information. So you've completely separated all the parts of the code and kept them clean and really small individual chunks. They're doing specific tasks. So this is a lot more work up front, but as you see, the more you build programs and the more they get complicated, this really is the benefit of your code is completely portable, can be used cross-platform. You can change the UI much easier. There's no hard ties in the background. So it looks like a lot of work, but like I say, this is a much better way of doing things, and you'll see the more you go what the benefits of doing this are. So they're the public properties. Now you also have in view models, instead of having functions like this, so you still have a function, but for the UI to call a function, you don't tend to have a function, you have a command. And again, it's basically just a function, but a command you want to, like on a button. So if you've got a button on the UI, because the button is just that, you can click it and it'll do something. No button on here, but you know what a button looks like. When you click a button, you'd want it to run a command, and it's got to be a single command with no arguments, because that's just what you should do in a view model. The view model's self-aware. It shouldn't have things passed into it. It should be self-aware based on its own properties. So you want commands as well, and think of commands just as functions. And we need to create a little helper here. So you've got a command, and it's called iCommand. And then we'll call this the expand command. Command to expand this item. And now in order to run, we need to create a type of command. And we just want to run a function. So we'll just create this little really basic thing. We'll just call it I'll just call it a relay command. It's just going to relay the action, to a command. It's just doing what it's doing. So let's just create this little relay command first. And that is just going to be, get rid of all this junk. Again, this is just something that's going to run an action. As simple as that. There's nothing magical going on here. So we've got to implement the iCommand. And let's see what that entails. So can execute changed. Let's just make event handler, so it's send an event. We'll just create a blank function for that. Or is that expecting a return value? And I was quite happy there. So that is your blank. The event that's fired when the can execute, which is a function, can execute method value has changed. So can execute with a function. So in this case, we just want to return true. I think that's how you do that. I know you can inline a function nice and easy somehow. See if I can get the syntax right. No, okay. Well, I know there's a way to really quickly inline a function. I really want to do it now. I know there's a way of doing it. I'll do that in the next video. So let's just do a normal function for now. So a relay command can always execute. So that's just a that basically says, like, say you bind to a button, you bind a command to a button, the can execute is what will make the button be either grayed out, like unclickable like these, or whether it's available. So this can execute is basically saying, can I do something? And if a button can't do something, then it doesn't allow you to click it. But in this basic just, relay command, we just wanted to run a function. We're just saying we can always execute. So let's just wrap these up. And then in the constructor, we want to pass in an action, so something to run. We need to store that. So an action is just basically a function with no parameters and no return value, just a plain action. You can do actions that pass in parameters, but think of this as just a blank function, like this execute, but with nothing in there. Just as literally just a function like that. So call it maction, and then when we pass that in, we set it here. So you can now construct a relay command and you just pass in an action. That's just the action to run. And then these are finally the command methods. So then the execute just simply wants to run the action we passed in. So that's it, that's all that's going to do. So this is now an I command that we can bind, and the relay command will simply run whatever function we pass in the constructor. It's just as simple as that. So on this we need a constructor as well. And then in the constructor we need to set the expand method. So expand command equals a new relay command, and we just pass in expand, the function we've already made, and that's it. So now that's now a command that we can bind to in the UI that then calls this function. So now we need to actually fill out this function to do something. So the expand is going to do, I think we deleted it and then I don't think I've got it in code anymore, but we can redo it. So this is when you've got a drive and you click to expand it. So what you want to do is, firstly, a file can't expand. So we just want to make sure we're not a file. We shouldn't ever be, but we'll just add that check. So if this.type is file, return. We cannot expand a file. And then we now just need to set the children to the new data. And we've already done the, oh, that's why, we did the work in this directory structure. So the children is just directory structure dot get directory contents, and it's the full path, and that's it. So now we've got a list of all the directory contents, and it's a directory item. Well, we need to set it to a directory item view model. So we need to first do a select again. We need to cast the content to a new directory item view model. And I've forgot this needs to be, we want to set the full path and the type. So you want string full path item type, full path of this item, type of item. Set them up. And the reason I'm doing these inside a constructor this time is because we've made this helper function clear children, and we want to add this child if the type isn't a file. And then, as you'll see from how the code will run, if we specify this type afterwards, after creating it, then this can get called before we've set the type, and it can invalidly add children to you know, a type that is actually a file. So we just make sure that the type's set straight away. That's the only real thing we need to pass in is the type, but we might as well then just pass in the full path and type. So oops, close the entire thing down. So the children equals, it wants to be this new directory item view model. It's simply the contents full path and the contents type. So that gets us to there. And then we want, this needs to be an observable collection, not a list. So it's just a new observable collection. And there we go, it's a single line now. So we basically say when you expand, find all children. And you could find it easy. You could split this down if you wanted to be, you know, not just a single liner. You could do like children equals the get directory content, and then you make a new observable collection from the children, and you're basically casting the children to a directory item view model. So that's all you're doing there. So that's the expand done. We've got now a view model for each item. And now the final thing we need, I think, to piece this together is the view model for the whole thing, to keep a list of these items. So let's make one more. Let's tidy this up a bit. Base. Let's make one more view model, and this is going to be the view model for this actual view now, the tree view itself, the view of the whole directory. So we're going to call this directory structure view model. Get rid of all the crap. Make it a base view model. The view model for the application's main directory view, and this one's going to be really simple. So we have a public observable collection, which is again just a list of directory item view model, and this is just items. So a list of all directories on the machine. So this is effectively going to be the logical drives, and that's what we want it to be. So we need a constructor, so I want to tidy this up. And then when we create the view model, the main overall view, we want to set the items to be, again, a new observable collection, and we want that to be the directory structure.get logical drives, and then we need to select them, and just as we've done all the others, basically cast them to the view model. So we'll move this out to children to keep it a little bit shorter. And then create the view models from the data. So this is going to be children.select, and that's a drive, and we want it to be a new directory item view model, and then that's just going to be the drive.fullPath, and the type is a drive. There we go. And I think we're basically there. So we've just got to hook up the UI to this. And the beauty of this is we can actually test this works without hooking up to the UI first, if we wanted. So let's just go to the view, and let's in here, let's just create a new directory structure view model, and that now should have the item should be the drives. So let's just presume we've got one, and then we'll tell it to expand. So we'll execute the expand command. In fact, let's do var item1 equals d.item0, so we can inspect and check there's nothing. Then we'll expand it, no parameters in this case, and then we'll check it again. So if we run this code, we're not bound to the UI yet, but we're just proving the view model. So we get a directory structure, we go in, it creates it, it asks for the logical drives, which we know works, so we get just a bunch of directory items, which have got the full path and name and type set. We then, the items as nothing, we then create a collection of them, which is now the view model. So now we've got the full path, the type is expanded to false, but it can expand because it's a drive, and we've got the expand command ready. So that's a bunch of items. So we've got the directory structure view model, which has now got items which are view models, which are all, you know, each drive. So we get the first one, and you can see the first one, the C drive, we haven't expanded it yet, so there's no children, which actually is an issue because we should have a single item in there. So when we create this item, I think we want to, or we need to, add the null item. We need to clear the children when we create, because obviously when you first created that, you've then got to add the initial item. So we need to go back and in the constructor of this here, we just want to clear the children. So that's why we wanted this type here. And now just do this dot clear children. Set up the children as needed. So now when we run first child, there we go, we've now got a single null item, and that will allow the UI to then have the expandable icon, and we're saying we can expand. And then we're going to actually tell this first item to expand. So if we step into it, it's then going to run the action. The action is the expand. It's going to check the type, which is a drive, so we can expand. It's then going to ask for the directory contents of that path, which it gets, which it then creates all these directory items for us. And then it's going to cast those to view models, just like the last one. And now the children have got a load of view models. So now this item has now got 28 children of all view models, and each view model has got them, and again there's nothing that's ready to expand. So all we need to do is we want to bind the UI to this directory structure. So the initial structure is this, so the whole view is bound to this. So we saw how to do that. Just do this .data context is that. So now in our UI, everything inside the UI is bound to this class. So we're going to be bound to a view model that's only got items to bind to. So if we now go to the XAML, and then in here we now need to do items source is binding. So by default now this binding, because the data context, where are we? Because the data context is this, binding is referring to this object itself. Well, the TreeView wants to be the items, the list. A TreeView is a list item, so you want it to be, you know, a collection of these view models. So we bind it to items. So that's then going to find the data context and look for the property items in there. So that'll now bind the TreeView. So let's just run that and see what happens. So you can see now we've got the 3 items. We know they're the 3 hard drives. And now we need to fix the actual the UI, because now it's saying, you know, the name of the view model. So we need to change this code. And we'll do this a slightly different way. So we'll do, instead of these resources, we will get rid of, we'll keep this, because we're now not going to set a header template. I'll show you a different way of doing this. It's a little bit shorter and nicer. So we'll get rid of that. We want to style, because we still want to style the TreeView item. It's still going to be a TreeView item by default. So it's going to be X type is TreeView item. So we want to create that style. Now we want the setter. We'll bind the property is expanded, so that when we click the expanded icon, if we bind this to our view models, so we go now to each item, because these items, if we go to the structure view model, each item is going to be of this view model type. So now in this part here, what we're binding to, because this is per item, we're now binding to a directory item view model. So we're now looking at this class, and we want to bind to this property we made called is expanded, so that when the UI changes from being collapsed to expanded, it fires this event for us. It sets our property. So to do that, we do is expanded, and the value is binding to is expanded. And by default, I think the mode's one way, so it doesn't bind both ways. So we want to do 2 ways, which means that if the UI updates, it will update our view model. It'll update this property, and likewise, if we set this property, it will also update the UI. So it goes both ways, but mainly it's so that when the UI updates, it will fire this property is expanded here, and actually then tell us that when it expands here, we want to then run the expand function in order to set the children. So that sets up the binding for the is expanded just through a style. Oh, actually, you can't just put that right there. I missed one step. It's got to be the TreeView item container style, so that it sets the style of the container, if you will, which is effectively the thing that hosts each item, so that it will style. So that's basically the exact same way as what we did previously, where we overwrote the header template, but this time we're overriding the whole template to the item, and it just looks a bit nicer. It's also a little bit shorter code. And now we want to actually replace the whole template. So this is the style, you know, the container style, not the actual the UI. So now we want to replace the item template itself. The item template is a hierarchical data template, and because obviously you've got the item itself, which is the TreeView like this, but it's hierarchical because this item itself has children, which is going to be these. So a hierarchical data template is the item, which is a TreeView item, but it knows that it's got to contain children, you know, these things that expand. So we also need to then bind the children to the children here, so that then it carries on down the line, that then the inner items are bound to the view models again of the children. So this hierarchical data template, we set the item source just like we've set here. So you think of it as like this infinite list, that the first ones are bound to the items, which are the view models, and then their children get bound to the children of that item. So that's where this constant loop goes. So this is this class, and then there's children in the class which are of that type. So this is where you get that continual loop. So for that you do binding to children, and again bear in mind that each item is bound to a directory item, not to the structure, because it's each individual item. So that will then bind the children, and now inside here we just simply paste the original view we had. We now fix the binding here, so that'll now bind to the whole view model. This, we want to bind it to the name, so we now just change the binding to name. And then the picture, well, now we can do this a lot easier. So instead of binding and going up to find the TreeView item and then doing a tag, that can all go. You still want convert, but now you can just bind to the directory item view models type. So this type. So just literally bind to the word type. And then if we just go into the header to item converter, we're now going to get a directory type. So we need to change, like get here full path, don't need that. We don't need that. By default we'll presume an image file, that's fine. But now we can simply do, we know the value is a directory item type because we bound to the type, which is this. So we just simply get that from the value, and we'll just do a switch on that value. And now we can literally do a much cleaner way, where if it's a drive, we set the drive. If it's a folder, we set the folder. And then you return the image, and that's it. So that's now again, you can see now how much cleaner that is, that even the converter doesn't have to mess with UI specific things. You don't have to have a TreeView item, it's now an actual it's a normal object. So this thing now should, if everything works right, this should all wrap up and show exactly the same as before. So let's see what happens. And there we go. So we've now got the first list, which means this this converter worked. So let's just see that. So it gets into here, the value is a drive, yep, so that works. Then they appeared, the reason they appeared is because we've got the item source set to items. In the background we create the data context of this new view model. So the view model gets created, it sets the items up here, which then effectively calls, well, we call logical drives, then we create the list from it. So that's where the items appear, and that's why these items get 3 items added. Then the template, get rid of this and this. So in fact I can just stop that. So this template then, ignoring that bit for now, styles the item template, binds to the name of the data item view model, which works out as the actual name of the drive, and then binds to the converter for the image. So that's where we've got so far. Now when we click expand, because we've got this property as expanded, bound to when the TreeView item actually expands, what we should get is we should hit this is expanded set value here, and you'll also see the get when it gets asked for it. So if we run this again, this is now the UI asking what the property is, asking whether it's expanded or not, which will all be no in the first instance. And when we click to expand, the UI is going to check what it is right now, which is not expanded, and then it's going to say, right, I want to set it to true, then I want to expand. So that's the UI firing off this event. So if we looked at the call stack, don't know if I'd see, you see, you're not seeing anything because that's come from the UI. So that's basically the UI firing and saying, right, I've changed to true. So at true, we then expand. So then in the expand, we should be a drive, which we are. Get the directory contents of the drive, which we've already checked this. So we've now got 28 children. So now this binding here on the template, which should be bound to those children, should now mean that because we've expanded and the children have now been set here, that we should now get a load of inner items that then starts this loop over again, that we then get new inner items that get the expanded property bound, which kind of replaces that folder.expanded event we made when we hand coded it. This sort of replaces that. That's how the expanded gets called. So if we run this now, and then you can see it's getting the other two. It's refresh. Actually, these are all the inner ones now. This is every inner item being asked if it's expanded or not. And you can see there we've now got the expanded menu. We've also not got the arrow here because the logic to when we clear children hasn't added this blank one if it's a file, so we don't get the expandable icon. You can actually double click to expand, so this is where this will actually come in. I think if you double click, yeah, it tries to expand, and then we've luckily caught it here. So there is other ways to expand without the arrow, so that check has actually prevented that from happening, which is good. And then obviously you can just keep diving into each directory and it just goes in a loop, does exactly the same thing. It's now just a repetitive binding of exactly the same style, and that's the view model done. And the benefit with, again, well, I guess not the benefit, but the beauty of view models is when you're finished, you take a look at the UI. So this is the UI. We've got nothing unloaded. We've got just a tree view with a style. We bind to the items for the main one, the children for the sub, and the name in the picture. So we've got like 1, 2, 3, 4, 5 bindings in the view. Just simple bindings with statements. There's your entire UI. You go to the code behind, which is this, and you've simply bound to a view model. That's it. That's your entire WPF. That's all there is. These two pieces of code, and yet when you run it, you get this complete working product, if you will. And a lot of the time, even when I do it today, is you still get amazed by when you finish how it just works. You're like, oh, I haven't told it to, I haven't constructed this view with code. I haven't sat there and said, when you click this, expand this, when you do this, go there, if it's a file, don't show this. It's all done through binding. So it's sort of cool to see that you're thinking, well, hang on, how is this working when I've clicked this? And you have to think about, oh yeah, because I bound here. And that then, as a consequence, goes into my view model and calls the expand, which then sets the children, which then fires the property changed, which then causes the UI to update itself. So it's a real sort of head twister sometimes to some people how view models work. But now the benefit of this, as I've mentioned quite a few times, is you can now scrap this UI and all you do is delete this one file here and delete this one line here, and now you can go and take this view model and move it to a Windows Forms application or to an Android app or an iOS app, and all you've got to redo is this tiny bit of binding. That's it. All you've got to do is bind to the new properties, so your code's now much more portable. So in a nutshell, that's view models. It's a very basic introduction, but hopefully it's made it clear and obvious what a view model is, which is nothing more than, as we mentioned, we'll go to a base view model. It's nothing more than something that overrides this notify property changed. When you bind into the UI, again, nothing too magical is happening. When you bind like here, it hooks into the parent of this items, which is this itself, this directory structure, and it listens out for its property changed event here, which we fire when we set the children, and then the UI goes and then asks for those children at that point in time. So it all just works through this property notify changed event. And then to get rid of the need to keep writing manual code that calls those property changed, we just went on the references, manage NuGet packages, and we searched and installed this Foddy property changed, and then for each view model we just created a base one so we didn't have to keep doing it. We just simply put this tag here, and that then fires this for us when we have view models that simply do this. So it makes our view models look like plain normal classes. So yeah, hopefully this has been a good tutorial to show you how to do view model binding without going too complicated, and to show you how we've converted an existing working product from a standard way into a view model way. And I know it looks more complicated and there's a lot more files, but trust me, this is a much cleaner and more beneficial way of doing your code, and it's completely separated. We've now got a helper class that you can use anywhere else. You can unit test, you can do a lot more with. This is just, you know, the best way of doing it. And the main, if you're trying to think of, well, why have we done all that work, just think about apps today are not just on Windows. They're on multiple platforms. They're on Mac, Linux, they're on like embedded Windows, they're on Androids, iOS, you name it. There's so many places where your code's used, and this code can be used in .NET Core, which means you can literally compile all of this code, with the exception of this tiny UI class, into a completely cross-platform code base using .NET Core. So that means you could literally take this exact project right now and run it on the iOS, and all you'd have to do on iOS is to create the UI. So just create a basic stack panel that shows, so I'm going to show you what it looks like. Yeah, you can't see it, but you've seen what that looks like. You just have to create the stack panel that shows an image and an expander and a name, and that's it. That's all you'd have to do to make it work on iOS. So we'll do more obviously on the view models, but now in future we'll start moving all these things like base view models and all the helper stuff into like a core library, so we don't keep repeating ourselves. And then I'll put all this shared code on GitHub so you can download it, and new products can start making use of these, you know, things we're starting to create now. I think in the next video we are going to start moving on to the chat application. We may do a few little things in between, maybe a few little bits of game logic or whatever takes a fancy, but the goal now is to start making the UI for a full chat program, and then we can now use view models to do that, and you know, we'll go from there. So I hope you enjoyed this.